Welcome to video number 2. In this video, we're going to create our first functional application. It's going to be a Hello World app. So our goal is to have a label which can display text and a button on the screen. The label is going to say Hello World, and then when the button is tapped, it's going to change the text of the label to say Goodbye World. Obviously, this is a very simple application. It doesn't really do much, and it's not really useful in any way. But that's not the point. The point here, the goal, is for you to become somewhat comfortable with the concepts behind writing an iPhone application. Some of the concepts, anyway. Obviously, it's going to take a lot of time and practice and effort to become an expert developer, or at least a moderately good developer. But that's okay, because like with anything else, you take it one step at a time. So, to begin, let's open up Xcode. And again, we need to create a new project, either by clicking Create a new Xcode project in the Welcome window, or you can go to File, New, Project. Okay, again, we're going to choose the single view template because that's completely sufficient for what we're trying to do here. I'm going to call the app Hello World. I'm going to leave organization name as my name and the company identifier as Tony Friz Inc., as we did with the introductory video. And of course, the devices needs to be set to iPhone. And again, like last time, I'm going to create the project folder on my desktop. Okay, so let's begin by discussing the significance of all the files in the Hello World group folder. These are essentially all the files you'll be using to write an app. First is appdelegate.h and appdelegate.m. In Objective-C, a class is defined with two files, a .h, which stands for header, and in that file you basically outline your class, and a .m, or an implementation file, where you implement all the methods that that class can respond to, or that class can execute. So you can see Apple automatically generated a class for us called App Delegate. The purpose of App Delegate is to essentially oversee the broad general activity going on in your application. Likewise, it's responsible for responding to certain application-wide events that happen to your application. Every single application has an App Delegate, and every application has only one instance of the App Delegate. When an iOS program is launched, a singleton instance of the App Delegate class is created automatically, so you never have to actually initialize an App Delegate. Don't worry too much about exactly the purpose of the App Delegate right now, because we're not really going to be using it in this application. But what we'll do is we'll go back to the H file and then back again to the M file, and we'll discuss some of the stuff we see. So let's go back to appdelegate.h. Again, as I said before, an H file, a header file for a class's definition. Every class has a .h and a .m file that come together to define that class and explain how it behaves. The .h file is where you give your class an outline. So here, we're giving an outline for the App Delegate class. The first line is an import statement. This is just going to import UIKit, which is the API you're using to write iOS apps. In other words, that's Apple's written standard library for iOS development, the library that we'll be using for everything. Next, we have a line that says @interface App Delegate, and then a space, and then a colon, then another space, and then a keyword that says UI Responder. And then next, finally, inside of some brackets, UI Application Delegate. So first, @interface. That's an Objective-C keyword that tells the compiler that you're about to outline or interface a class. Next, we have the name of the class, App Delegate. So we're telling the compiler that this class's name is App Delegate. After the colon, we tell the compiler what class this class descends from. In other words, the keyword or the class name to the right of the colon is the superclass or the parent of this new class that we're defining. So, App Delegate is a subclass of UI Responder. Obviously, UI Responder is a class that comes with UIKit that Apple has written. We're not going to worry exactly about what UI Responder is and its purposes and when you'll need to make one and what classes have to descend from it. Right now, just understand that App Delegate is a new class defined in these two files, and it descends from UI Responder. In the brackets here are listed protocols that this class essentially promises to implement. A protocol is a list of methods that allow you, the developer, to respond to certain events that take place elsewhere. So for example, one of the methods outlined in the UI application delegate protocol is a method called application did finish launching with options. This method is sent automatically to the app delegate instance, the singleton app delegate instance, when your application has finished launching. In other words, as the developer, the SDK is giving you a chance to execute whatever code you would like when the application finishes launching. And we'll take a look at that when we take at the .m file in a little bit. Again, this too don't worry too much about, since this also is outside of the scope of what we're doing in this application. Next, we have something called a property. As you continue to write iPhone apps, you'll see that almost always you're going to make use of these things called properties. And you'll learn the nuances and uses of these properties as we progress. But for right now, let's just say that a property is basically a public instance variable. Assuming that you have some knowledge or background with object-oriented programming, you know that a class has instance variables and then methods or functions. Instance variables or variables internal to that class that it can use to store data that it needs to perform its function. But in most programming languages, by default, these instance variables are only accessible from within the class they're defined for. And historically, most object-oriented programming languages require you as the developer to implement a getter and a setter method for each individual instance variable if you want to make that instance variable readable, writable, or both from an outside class, from another instance of a different object. But if you have a lot of instance variables and you want to make all of them or most of them public, writing a getter and a setter method for each instance variable becomes very tedious and kind of feels like a waste of time. So the solution to that in Objective-C anyway, thanks to Apple with Objective-C 2.0, are these things called properties. So this here tells the compiler that App Delegate has a property of type UI window and it's called window. This way, other instances or other objects can access the App Delegate object's window property, and we'll see the syntax for accessing an object's properties later on. But first we have to take a look at the asterisk here before the variable name window. If you have a background with C programming, you know that C is famous for something called pointers. Pointers are variables that point to a location in memory on a computing device. This way, you can directly access and modify the data contained in a particular memory address. Since Objective-C is based on C, it too has these things called pointers. It turns out that using pointers for object-oriented programming language in C is an absolute must. If there were no pointers and you created an object and you wanted to send that object somewhere else, maybe pass it into a method, when the method is executed, a local copy, just for executing the code inside the scope of that method, would be made for that object. In other words, all the data that that object contains, namely in its instance variables, will be replicated, and then the method will use that duplicate to execute its code. That's unacceptable for two reasons. The first reason is memory on whatever computing device is running your application would become scarce very, very quickly. The second reason that that method's no good is because when you're reading and making use of the data a particular object contains, you want to work with that actual instance, not a copy of the instance. If you work with a copy of the instance and you try to do something with that object, anything you do is going to be done to the copy of the object, not the original object. And so if, for example, you wanted to manipulate some data that the original object stores, you couldn't. So the solution to these two problems is objects are passed around as pointers. So this property here, or this instance variable called window, stores a location in memory to the window object, to that particular instance of the UI window class. You'll see very quickly that pointers are used all over the place when writing iPhone applications. In fact, sometimes you'll be using nothing but pointers. Now let's discuss what a UI window is. A UI window is essentially a view that represents the entire window on screen when your application is running. You can place anything you like inside of that window, and as long as that window is the key on-screen window, whatever you put inside of it will be automatically displayed in your app when a user is running it. As you might have guessed, that too is set up automatically by Xcode when you create an application from a template. But if you wanted to, you could create additional UI windows and swap them on the screen and off the screen as you please. Inside these parentheses here are keywords you can use to describe how this property behaves. We're not going to worry about this right now, but in the future, you'll see that it's very important that you understand the significance of each of these keywords, or attributes as Apple calls them, for a particular property, because in some cases, one particular attribute might be necessary, whereas another one might have to be omitted. And finally, to conclude the outline or interface of our class, we have a keyword that says @end. As you probably have already guessed, all keywords in Objective-C begin with the @ symbol. Let's move on to the implementation, or the appdelegate.m file for our AppDelegate class. As I said earlier, this is simply where you implement all the methods that this class can execute. All of the methods that you see here right now that were automatically implemented by Xcode when we created the project are methods that are part of the UI application delegate protocol that we talked about earlier when we saw its name inside of these brackets. So for example, when your application finishes launching, which means the user has tapped on its icon on their home screen and then the iOS device opens the app, once it has finished launching, this method here will automatically be called. In other words, any code you put inside of these two curly braces will be executed automatically when the application finishes launching. But now let's take a step back and examine this file from top to bottom. So first, we have an import statement that imports the header file. That's pretty self-explanatory. If we try to implement a class called App Delegate without telling the compiler who App Delegate is, it's going to get confused and obviously throw an error. We begin the implementation of the App Delegate class, or any class in Objective-C, with the keyword @implementation, followed by a space and then the class name, which is again App Delegate. And again, inside of this implementation, until we reach the @end keyword at the bottom, are implementations for all the methods you might want to execute. All of these methods, like did finish launching with options, are called automatically when that particular event takes place. Now this is not the case for all methods. Not every method of every class that you write is going to be called automatically. But in many cases, some of the methods you implement will be called automatically. And this is a good example of some of those methods. So the next one, application will resign active. This will be called automatically when your application is about to resign its role as the active application. This application did enter background will be called when your application has officially gone into the background and is no longer the forefront application on a user's device. Application will enter foreground. This will be called right before the user opens your app back up, and so on and so forth. Now let's take a look at the way that a method header in Objective-C is written. So first, we start every method header with either a minus symbol or a plus symbol. A minus symbol indicates that this method is an instance method, and a plus symbol indicates that this method is a class method. An instance method is a method that can only be called to an instance of an object. This is because that particular method uses or modifies an instance variable. Of course, if you don't have an instance of a class, there are no instance variables to be used or modified. And in that case, an instance method can't execute its code. And then, so obviously, a class method is a method that doesn't make any use of a class's or object's instance variables. It just performs some static code. And you can call that without an instance of the object. You can execute the method by making a call to the class's name. Next, we assign a return type to this particular method. Void, as you probably already know, means this method doesn't have a return type. It doesn't return anything. And if you read the method header and read in the comments the purpose of this method, you can figure out very quickly that this method doesn't need a return type. The first method, application did finish launching with options, is an example of a method that does have a return type bool, which is yes or no in Objective-C, where yes is analogous to true and no is analogous to false. After the closing of the parentheses with the return type inside, we have all the parameters or arguments for this method. When writing iOS or Mac applications with Objective-C, it's conventional to describe exactly what the method's doing, as you would if you were to explain it with English, by naming all of the arguments such that if you split the header up word by word, it could read like an English sentence. So for example, application did enter background is very semantically descriptive. This way, you can figure out very quickly a particular method's purpose. I advise that you follow this convention when you write iOS apps. After a particular argument's name, there's a colon, followed by, in parentheses, that particular argument's type. For this argument, the type that will be passed in is UI application. Whenever an iOS application is launched, an instance of the class called UI application is created. And that object, which too is a singleton object like App Delegate, essentially represents your application. It stores information that identifies your app from other apps on a device, and it's also able to perform application-wide modifications. For example, hiding the status bar that appears at the top of an iOS device. Since this is an object and we're working with Objective-C, the class name is followed by an asterisk, since this argument is simply a pointer to that UI application object. Finally, after the closing parenthesis, we have the variable name for that particular argument. Let's move on. The next file is main.storyboard. A storyboard file allows you to create an interface for your application using the Xcode built-in GUI, or graphical user interface. So for instance, you can create a UI kit object by finding it in the object library, which is at the bottom right of the utilities panel, and dragging it onto the screen. You can create a label and place it on the screen programmatically, but it's usually quicker and more convenient to do it graphically. Now, not all interface files for writing iOS applications are .storyboard files. A storyboard file is something Apple came up with relatively recently, maybe a year or two ago, that allows you as the interface designer to design and display the flow of your application. So for example, if you want to go from one view to another view, you can use a storyboard file to visually show how those two views are connected and the relationship between them. You'll understand this better once we start to make apps with multiple views, but since in this application we only need one view, you can forget about the real purpose of a storyboard file for now. The arrow on the left of the view here indicates that this is going to be the first view that pops up when the storyboard file is loaded and displayed inside of your application's window. If we take a quick look at the app settings, you can see under deployment info that main interface is set to main. This means that when the app launches, the main.storyboard file is automatically loaded and automatically displayed on the screen. If we were to change this or leave it empty, we would have to programmatically load and display the storyboard file on the screen. So all this really does is save us one step. Now let's take a look at viewcontroller.h. A view controller is an object that manages and maintains a view. With iOS app development, Apple likes themselves and third-party developers to follow the MVC or the model view controller pattern. In compliance with that pattern, a view controller is the controller and the view that it maintains/manages is the view. Since this view controller doesn't have any instance variables and doesn't manipulate any data, it doesn't really have a model. Obviously, viewcontroller.h and viewcontroller.m too were auto-generated by Xcode when we created the project. Just like with appdelegate.h, viewcontroller.h interfaces or outlines our viewcontroller class. Xcode automatically named our custom viewcontroller class viewcontroller, and it's a subclass of UI viewcontroller. A UI viewcontroller is a standardized viewcontroller that has a lot of important functionality for maintaining a view already built in, and by creating a subclass of that, we can make our viewcontroller store and display any data we like. Finally, we have the @end symbol to indicate to the compiler that this is the end of the interface for the viewcontroller class. Let's revisit main.storyboard for a moment. This giant white box, represents an instance of the viewcontroller class. In other words, when the main.storyboard file is loaded when the app's launched, an instance of our viewcontroller class will automatically be created, and this is essentially it. Down here, what looks like a circle with a view inside of it represents the instance of viewcontroller, and the white box here represents the view that it maintains. In other words, if we put something inside of this white box and then we display the viewcontroller instance's view on screen, whatever's in this white box or this white view will be displayed on screen to represent that viewcontroller. So again, a viewcontroller manages a view, and that view can be placed on the screen. If we click on the icon down here that represents this instance of the viewcontroller class, and then we open up the identity inspector in the utilities panel, you can see that the class type for this object is viewcontroller. So any changes we make programmatically to view controller's view in its implementation file will be done to this view here. Let's take a look now at viewcontroller.m. You can see that its implementation file looks similar to the appdelegate.m file. For now, there's only one method we're going to be concerned with, and that's this one here. When an instance of this viewController class is created, and its view is displayed on screen, whether programmatically by you or automatically when the app's launched, this method will automatically be called right when the viewController's view finishes loading, and you can make any changes to the view right before it's displayed on the screen that you like. Let's take a look at how that works right now. So first, let's go to main.storyboard. Let's drag a label from the object library onto our view. And let's leave its text to say label. Let's save and run our application. So, as we expected, the label's text still says label. Let's stop our app, take a step back, and talk about what a label is. A label, whose class name is UILabel, is an object that comes with UIKit that allows you to display some text on screen. You can change its color, its font size, its background color, etc., etc. One habit that you definitely need to form if you're going to be a serious iOS developer is to reference Apple's class documentations. So let's open up the browser and search for UILabel. If you click on the first link, UILabel class reference, on the Apple developer website, and you scroll down a little bit, you can see everything you can do with a label. Any item you see that has the word property next to it is a property of the UILabel class. All of them are readable, and most of them are writable. So for example, you can change the font of a label. You can also change the text color of a label. The one we're going to be concerned with is the text property. You can use this to change the text that the label displays. So now let's go back to Xcode and make this happen. First, let's set the text to Hello World programmatically in the viewDidLoad method. So let's go back to viewControl.h, and we need to make an instance variable so that we can reference that label, the label we just created, from within our code files. It's great that we can make a label that quickly just by dragging and dropping from the object library onto the screen, but unless we have a way of referencing that label from within our code files, it's useless. The way that we can do this is by using something called IBOutlets. An IBOutlet is a particular instance that points directly to the object that we created using Xcode's GUI. So we're going to make an instance variable called ourLabel that points directly to the label that we created here in main storyboard. The syntax for that is IBOutlet, UILabel, ourLabel. Now I'm sure you noticed I added an opening and a closing curly brace to viewController's interface. Inside of these curly braces are where you can give a class its instance variables. So we now have an instance variable of type UILabel named ourLabel that is an IBOutlet. So now we can right click from the viewController object and drag to the label. Let go once you've reached the label, a little HUD will appear, and you can click ourLabel. And now you can see, indicated by the circle, the ourLabel instance variable points to this label that we created graphically. So now, any changes we make to our label programmatically will be made to this label here. So now let's change this text to say hello world in the viewDidLoad method. Again, this method, viewDidLoad, will automatically be executed as soon, right before the view is going to be displayed on screen, such that these changes are made before the user gets to see your view on screen. So the syntax for that is ourLabel.text equals hello world, in quotes, started by an @ symbol. So first, we're referencing our label. Then we use the dot syntax to access its text property. And then we set the value of the text property, which stores an NS string, which is also an object that comes with UIKit that allows you to store and manipulate a string to @hello-world. In Objective-C, all strings begin with the @ symbol. So now let's run our application and see what's different. So as we hoped, the label's text was changed from label to hello world, and we were never able to see the change. It happened before we saw the view. But you can see that it's being truncated at the letter E, and this truncation is indicated automatically by 3 consecutive periods. The solution to this is to increase the size of our label. We can also center it by opening up the Attributes Inspector, going down to Alignment, and choosing the second option. Let's make it a little bigger, just to be safe. Let's save and run our application again. Perfect. Now, let's add a button that when pressed, the label that says Hello World has its text changed to Goodbye World. So let's stop our application. First, let's place a button onto our view. So scroll down, find Button is an instance of UI button, and drag it onto the view below the label. We'll change the button's title to Change Text. Now we can save. Now that we have our button, we need to provide a way so that clicking on it sends a message to our view controller so that we can programmatically change the label's text from Hello World to Goodbye World. We can do this using something called IBAction. Let's go back to viewcontroller.h, and we need to add this action to our header file. Method headers in a class interface file are added after a class's instance variables but before the @ symbol. An IBAction is formatted like this. A minus symbol to indicate that this is an instance method, open parentheses, followed by the return type. We can indicate that it's an IBAction with the keyword IBAction in place of the return type, but that essentially means void. The reason we set the return type to IBAction is so that when we go to our main.storyboard file, our view controller has an action that a control item can trigger. So now let's go back to the H and finish outlining or providing this method's header. We'll call it very simply Change Text. Now we can connect that button to this Change Text method in our storyboard file. So we can right click on Change Text, drag down to the view controller object, and select the Change Text Sent Events. So now, when this Change Text button is pressed or tapped on, it will send a message to the view controller telling it to change text. But now, we need to implement this change text method. In other words, we need to provide the code that's executed when that method is called to. Let's do this under the viewDidLoad method. So, we provide the method header just like we did in the interface file. But now, inside of curly braces, we give some code that will actually be executed. We can follow the exact same pattern we used to change the label's text to Hello World after the view loads. Our label.text equals Goodbye World. Save and run your application again. So if we press the Change Text button, the label's text is changed to Goodbye World. You can see we've reached the goal we set out to reach at the start of the video. Don't be scared off if some of the principles we introduced didn't fully make intuitive sense. Because as we progress, you'll get used to these syntaxes and these principles, and with enough repetition, you'll be able to implement these types of actions without a second thought. Well, that concludes video number 2. Head on over to video number 3 for some material that's a little bit more complex.